Believe it or not, this video is about microcontrollers. This big box may tell you otherwise, but we're talking about the microcontroller that controls power conversion inside of it. It's a GD32 G5, and I would love to find out some more, so let's go talk to GigaDevice. Sharam, every good interview typically will start with a handshake, but today we've got our hands well full.
That's true.
What is in our hands today?
It's a 12 kilowatt reference design for AI data center PSU, power supply unit, that we jointly developed with Navitas Semiconductor, one of our partners in our newly introduced power lab that we have in China.
Yeah, maybe we should put this down now.
Yeah, let's do that.
Wow, it's so heavy, oh my lord. We're causing booth havoc. Now, we've got some AC coming in, we've got some DC coming out. The way that I know GigaDevice is for memory and processing, right? So you've got your NOR memory, you've got your NAND memory, you've got your GD32 range of microcontrollers. So what the hell are you doing here?
It is actually one of our microcontrollers that is special purpose built for power devices. In this case, we have a GD32 G5 lineup microcontroller that's focused on digital power. Because in this case, we're using gallium nitride and silicon carbide to be able to deliver the power density that's required in this form factor for AI data centers. In order to take advantage of those new wide bandgap technologies, you want to have the right type of microcontroller can adapt to that high switching frequency.
Cool. What is your GD? So it's GD32 in here. GD32, which one?
G5.
What is it actually doing in here? Is it controlling switches, or is it monitoring? What is actually the role of the microcontroller?
Yeah, it's supporting the high switching frequency of gallium nitride and silicon carbide. We have three types of hardware accelerators in this microcontroller that offloads all of that math processing out of the M32 core that's in the GD.
So this isn't even running in your loop, in your main function. This is all happening. You've set this up.
The hardware accelerator, yeah.
Right.
So there's a FAC unit there.
A what unit?
FAC.
I don't swear.
It's actually FAC, which stands for Fast Arithmetic Calculator.
Oh, okay, yeah.
Right, so you can offload that function out of the ARM core onto this hardware accelerator.
Yeah.
So your actual core can run the other applications in the version here.
One more question I got. Why is there a GD32 in here? Why not something else? Why would you put it into this?
Again, it comes down to really the differentiation approach here, right? So we have a lot of general purpose 32 MCUs out there, but you have to pick a MCU that can adapt to the requirements for this specific application. In this case, again, because of use of gallium nitride and silicon carbide, you have to be able to adapt to the fast switching frequency. You have to be able to adapt to really high resolution PWM. This specific GD32 G5 product has high resolution PWM, where we can go down to sub 90 picosecond resolution. Picosecond resolution, right? Which that means that you can really take advantage of the processing power of the microcontroller to be able to deliver that.
Blisteringly fast.
As you can see, the efficiency for this PSU is 97.8%.
That's good.
For a 12 kilowatt, PSU in an AI data center, where power requirements obviously a big requirement there, because you don't want to create a lot of nuclear plants and plants and whatnot to be able to support data centers. It becomes every single 0.1% efficiency gain means real dollars to the end users of the data center.
100%. IPXs, we're going to have a lot of information of this available for you at ipxchange.tech, where you can apply to evaluate and check out this product for yourself, the GD32 G5. Brilliant. Great talking to you today.
Absolutely.